Assalamualaikum to NCS Hazarin and my beloved friend. Today we go to represent about scientific project PAM. Before we continue about our presentation, I would like to introduce my group member to you. This is my group member that I am Noain Fateh binti Mahmud. Second is Muhammad Nur Izwan bin Zulkifli. Third is Muhammad Uwas Al Qadim bin Sa'ad. Fourth is Muhammad Amin Rais bin Shahadan. And lastly, Ahmed Abu Ubaidah Babikar Abdullah. And we will continue about our project to introduction. For the introduction, turbo machinery consists of a mechanical device in which energy is transferred between a moving fluid to rotating components such as a blade or rotor, either to produce mechanical power or to increase the energy of the fluid. These machines are generally classified into a power producing device, such as a steam, gas, and hydraulic turbine that extract energy from the fluid, and a power absorb device such as a pump, compressor, and a fan that use the mechanical energy to raise fluid pressure or the velocity. Turbine machinery is essentially in a power generation, industry processes, and a fluid transfer system. In a typical steam turbine, high energy steam flow through the center blade and guide to acceleration the steam, converting the pressure energy to kinetic energy, which is a transfer to rotor blades to produce mechanical work by rotating. Next, for the background, turbomachinery is rotating fluid machine where energy is transferred between a fluid and a rotor or an imbalance. Its operate is based on conservation of mass energy and angular momentum. It's classified into a power producing machine such as steam, gas, hydraulic turbine, and power absorbing machine such as pump, compressor, and fan. For the power producing machine, it extract energy from the fluid to produce mechanical shaft to work. And for the power absorption machine, it requires a mechanical input to increase fluid pressure or energy. Next, for the turbine operating using an Euler turbomachinery equation that involving a change of fluid angular momentum to generate torque. Then, a turbine stage consists of a cylinder blade that acceleration and direct the fluid and a rotor blade that convert fluid energy into useful work. Lastly, for the multi-stage, high pressure, intermediate pressure, and low pressure are used to achieve efficiency energy extraction.
Bismillahirrahmanirrahim. So for my part is design specification. The centrifugal pump is designed to transport 0.65 meter square per second of river water to a tank which is 20 meter above through a 0.3 meter with 35 meter pipeline. A mixed flow single stage pump with a closed backward incline impeller was selected to handle high flow rate efficiently while maintaining stable performance. The impeller geometry, inlet and outlet blade angles is inlet 35 degree and for the outlet is 60 degree. Inlet radius is 90 is 90 millimeter and outlet radius is 100 millimeter. For the blade width is 40 and 50 millimeter and a speed of 3500 rotation per meter was optimized within project constraints to generate the required total dynamic head, which is 31.1 meter. The pump required 198 kilowatt hydraulic power and 254 kilowatt shaft power with a 315 kilowatt motor recommended for startup margin and reliable operation, aligning the design with industrial standard like the Andris SCP-SI.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Rais bin Sharan, and now I'm going to continue our presentation for week 2 for design analysis. Okay, for the analysis, first one is pipe flow velocity of pipe flow. I can see 0.3 diameter at flow rate 0.65 and our flow velocity is 9.2. So this mean high velocity mean different friction losses and must be considered in head calculation. And then continue with friction and minor losses. If, the friction loss is 6.8 meters, and we use the Dashim's formula or we use the figure and we have F equal to 0.018 and our minor loss is 4.3 due to fitting band valve and entrance and else. Combine these losses and we get 35% of total energy demand. Then we go for total dynamic head, where the static head plus friction and plus minor loss equal to 31.1 meter. Then we move to hydraulic and shaft power. We just assume the hydraulic power is 198 kilowatt. Assume the efficiency is 78. We have shaft power is 254 kilowatt. So we need to select for motor is 315 kilowatt for safety margin, startup torque, and reliable operation. And then we go to impeller energy transfer. Impeller chip speed at U2 36.65 meter per second. Flow velocity at outlet at VF2 20.69 meter per second. The tangential velocity VU2 is 24.7 meter per second. And the theoretical head via outlet equation is HE equal to 92.28 meter just efficiency and H actual is 31.3 meter. This confirms the impeller geometry and rotational speed meet the total dynamic head requirement. And the difference only 0.02. This so the suitability of the set pump in the mid-flow centrifugal pump require the head flow and require head and flow. The hydraulic behavior aligned with system demand and performance character match industrial pump like SCP-SI, validating this design both theoretical and practically. Thank you.
So, Assalamu alaikum warahmatullahi wabarakatuh. My name is Ahmed Abu Abeida. My trick number AD240165. So, now I will discuss the main point of our pump design project. The main goal of this project was to design a centrifugal pump that can move 0.65 cube meters of water per second from a river to a storage tank 2 meter above. Our analysis shows that the pump need to overcome a total dynamic heat of 31.1 meters to meet the flow. To do this, while keeping the pump small, we choose high speed and concept impeller design. This gives enough heat and good performance with our size limits. So first, system resistance and energy demand. We looked at the Prepel, which has a diameter of 0.3 meters. The water flow very fast, about 9.2 meters per second, which is the normal for large water systems. Function and other minor losses at about 35% of the total energy needed. This shows that when designing a pump for high flow, we must consider not just the height its need to lift water, but also the energy lost to friction and turbulence. Second, geometric observation. Big one challenge was the maximum outlet radius of 1 millimeter, 100 millimeter. Usually, a pump that lift 31 meter would use a bigger impeller and a slower speed, like 1080 RPM. But because of our size limits, we used a smaller impeller and increased the speed to 3500 RPM. This way, we still reach the need heat without exerting the size constraints. Third, compressor was
within terrestrial pumps. Even through this pump, it is custom made for our project. Its performance it is smaller to high performance in industrial pump like the others ACB. Those pump high power around 254 kilowatt and large water flow using background curve blend give a stable and effectiveness performance, which is important for river water pumping because water level and resistance can change. So fourth, efficiency and power. The pump need about, as we say, 254 kilowatt of shaft power, assuming 78% efficiency. We recommend 315 kilowatt motor and handle the external power needed at startup for the high water flow. The high speed of 350 rpm, 3050 rpm means we also need strong cells and presently balanced impellers to prevent version of confusions. These versions are common in industrial pump like Sulzer and Android's models. Thank you.
Hello, Assalamualaikum. My name is Muhammad Wais. My matrix number is CD230029. Okay, for the conclusion, a centrifugal pump for river water transfer was successfully designed using turbomachinery principles. The system delivers a flow rate of 0.65 meter cube per second at a total dynamic head of 31.1 meter, operating at 3,500 revolutions per minute with high efficiency. This power analysis led to selection of a 315 kilowatt, confirming that the design is technically sound and suitable for large-scale water transfer application. Okay, that's all from me. Thank you.